Hello everyone, how are you all doing? Welcome to IGBits. We train, you learn. Today we shall continue our topic work per energy. We will see some more sums. Alright, without further delay, let's get started. We have our YouTube channel. Visit us at IGBits in YouTube. Please feel free to subscribe and click on bell icon to get the notifications. Your support is very important for us to work together to share many more knowledge sessions across. Okay. Thank you all who are actually being with us and supporting us. This is a great platform that we are aiming for. Thank you all once again. Okay, let's look at this problem statement. A cyclist comes to a skidding stop in 10 meters. During this process, the force on cycle due to road is 200 newtons and is directly opposite in motion. Okay, how much work does the road do on the cycle and how much work does the cycle do on the road? Fair simple thing. Let's say we have a cycle, right? Right. So this is moving on the road. So due to the skidding, I think it comes to a stop in 10 meters is what is given. S is given, and then the force applied by the road. So basically, frictional force. The frictional force would be how much? 10, how much is 200 newtons, right? 200 newtons frictional force, which is opposite direction to the displacement, correct? So we know that fundamental formula W equal to Fs cos theta. How much F here? 200, and displacement is 10. What about cos theta? Theta value is like 180 because you look at force and displacement both are opposite direction. So we have 180 degrees angle here. Let's say 200 into 10 into cos theta, right? Cos 180. So cos 180 is nothing but minus 1. So minus 2000 joules. So basically what we are saying here is that negative work done to bring the cycle to the halt condition, right? Which is nothing but your work energy theorem. Okay, this is a part one. What is part two? Part two is talking about how much work done, how much work does the cycle do on the road. Let's look at same fundamental formula. F equal Fs cos theta, W equal to, right? So let's assume that cycle actually does some kind of work on the road. How much road displacement? In this case, there is no displacement in the road, right? This would be the zero, and hence the work is also zero. So what we are saying here is road undergoes no displacement and hence work done by the cycle on the road would be zero. Clear? Next problem. A body of mass 10 kg is moving on the horizontal surface by applying 10 newtons in forward direction. Find the work done by the force of friction. What we are saying is like we have body of 10 kg. Okay. Force is applying this direction and frictional force opposite negative direction. And the normal force is a upward direction and mg would be the downward direction. Let's say if g is also 10, mg how much? 10 into 10, nothing but 100. This would be 100. N equal to 100. So what is the, FBD says net forces applying on the body should be the zero, right? So that means N equal to mg, and frictional force is the force. These two can talk about. So W equal to frictional force F dot S, right? Means like Fs cos theta. Okay, how do you say now? This one, how much F? F would be 10 newtons. That's also given. So 10 displacement 2 and cos 180, because frictional force. So frictional force and the displacement both are, this is a frictional force, this is the direction, and both are 180 degrees apart. So this is nothing but 180. How much this value? Minus 20 joules. This is the work done by the frictional force, force of friction in this context. Clear? It's a simple one. Next problem. A body of mass 2 kg initially at rest. So let's put 2 kg. Okay. 2 kg initially at rest moves under action of applied horizontal force. Let's say you are applying an horizontal force F, which is of 7 newtons. So the coefficient of friction Fk is 0.1, maybe this direction Fk, and then mu k equal to 0.1. So we know this is a normal force equal to mg. M means how much? 2k into 10, so 20 newtons n. Fk equal to how much? Kinetic into r, mu r. So 0.1 into 20 equal to 2 newtons Fk approximately. Yeah, you can think that way, right? G equal to 9.8 meters per second square would also be equal to approximately 10 meters per second square. Let's assume per minute. So now we know net force. How much net force would be in the direction of the body, right? So net force would be 7 minus 2 is equal to 5 newtons, right? Okay, so what is needed for us? Work done. W F into S. We have F, but what about the net acceleration is what is needed for us. So net acceleration A equal to F net divided by mass. So 5 by 2, nothing but 2.25 meters per second square. Agree? So good. So now, given the data, I think you should be able to solve the problems. How do you get S actually here? S equal to ut plus half at square, and initial velocity is 0, and hence F acceleration 2.5 into what's time? 10 seconds, so 100, right? 2 to 1.25, which is nothing but 125 meters. So based out of this data, now you should be able to answer work done by applied force. Answer 1, W equal to F into S, right? Applied force is how much? 7 Newton into 125 would be your answer, right? Joules. What is the second one? Work done by the friction in 10 seconds. Frictional force how much? W equal to Fs, right? How much that is? 2. So 2 into 125 joules. So work done by the frictional force. What is the third one? Work done by the net force. Net force is how much? 5 newtons. So W net equal to 5 Newton into 125. Correct? Uh, so you can also, this is also joules. This is how you should be able to solve the problems. Are you clear? So the what is given is that 2 kg mass is given, initial velocity u is given, and then applied force 7n is given. Kinetic friction, coefficient of kinetic friction 0.1 is given, with which you should be able to find out the friction force, because mu into r, mu mg is what is given, and then time t is given. So common acceleration should be, you have to get from net force, which is nothing but applied force minus frictional force. So we now have a frictional force, applied force, net force, and then you have a time, and then you can calculate a common acceleration, the displacement, net displacement, with which you should be able to solve the work done by applied force, work done by the frictional force, work done by the net force. This is a good problem. Find work done from a given graph. So the graph is given, fx graph is given, and then you so asking us to actually solve the problem. Okay, so how do you calculate this one? Exactly, that's correct. Area under curve is nothing but your work done. Area under fs curve, right, would be your work done. Let's look at now. This area you have to calculate, this area you have to calculate and sum them. So work done equal to f into s, f dot s. So this is a triangle. What is an area? F b is 2, h is 5, plus this is a rectangle, 4 minus 2. The height would, this would be 5. So 5 into 6 minus 2. Correct? No? 2 ones are 2. So 5 plus 4 multiplied by 5 multiplied by 4. So 5 plus 20. So 25 joules would be your answer. Right? But I have a small, correction. So given that like this is meters, this value is correct. Otherwise, you have to convert to centimeter meter of story here. Okay. So area under fs curve would be your work done. That's hint. Okay, this is the homework problem. You will try out. If not, we will be doing this in the next class. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached end of the session today. We shall continue remaining in tomorrow's class. Thank you all who are joined and participated actively in today's class. See you all tomorrow. Stay tuned to next session. Thank you. Have a good day. Bye bye.